Okay, everyone, let's go ahead and begin our SPSS instructional lecture for binary logistic regression. Go ahead and open up your GSS dataset and your syntax file, okay? As usual, make sure you notate to yourself what we are covering. Week 14, binary logistic regression, okay? Now, I want to first begin by reminding you that the variables that you see here, that you see on my screen, are ones that we worked together on during class and recoded, okay? If you type these variables in and you run it and it gives you an error, it's probably because you did not create those variables and they are not in your data set. So you have to make sure that you have recoded the variables in the way that we did in class so that you can replicate these results that you see on my screen, okay? Again, remember, binary logistic regression is used when your outcome variable is binary. And in order for it to be binary, it has to be coded 1 and 0. It can't be 1 and 2. It has to be 1 and 0. Okay, that's because the 1 indicates the presence of something. 0 is the absence of something. And that's the only way the regression model can make sense of this information. Okay, I'm going to be using the variable abort, which we created in class by recoding the variable ABANY, okay, which asks respondents if they feel that women should be able to get an abortion for any reason, okay. This was recoded so that 1 equals yes, 0 equals no, and this was created into the abort variable, okay. So for the code, you want to type it out as follows: logistic regression. This first line here, variables equals, you want to put in your outcome variable, abort, okay. This first line is introducing the first set of variables that we want to estimate or assess in relationship to the outcome variable, okay? So in this case, I want to look at how it is that religious denomination influences abortion perceptions, okay? So I am going to include the dummies that were created from the denomination variable, okay? We created 4 categories: Protestant, Catholic, religious nuns, and religious others. When you are listing them here, because they are dummies, you have to leave one out so that it serves as the comparison group. In this case, I'm going to leave Protestants out because they are the largest group, okay? This second line introduces the remaining variables, which are essentially control variables. They are the demographic controls that are necessary to include and account for in any regression model. So we are going to include age, education, income, number of children, which are continuous, and you can just put them in as is. Male is a recode from sex, where 1 equals male and 0 equals female. We have black and other race, which are the dummies created from the race variable. As you can see, I am leaving out whites because they are the largest group and will be used as a reference group. Then we have marital status, which has the separated, divorced, widowed, and never married dummies, leaving out married as the reference group, okay? You want to type in the origin line and specify a printed summary. And then finally, you want to list the criteria for significance, okay? Let's go ahead and run the syntax, and I will warn you that the output for binary logistic regression is kind of scary and intimidating, but I'm going to just cut to the chase and tell you exactly what you need to look at, okay? Because there's a whole bunch of stuff that just is extra and that you don't really need to pay attention to, okay? Now, the first part that you want to jump to is this block 1, okay? This is telling us about the first model that we included, where we are just looking at denomination, okay? So block 1 are these variables, okay? Religious denomination. If we look at this model summary, you can see that it reports an R-square, which is a similar diagnostic that we reviewed during linear regression, and it works the same way. An R-square that is greater is better, because that means that the variables that you are including are doing a pretty good job at explaining the changes in the outcome variable. Okay, in this case, the R-square is about 0.05, which means that denomination explains about 0.5% of changes that we see in our outcome. Okay, so it's a low R-square, which we would expect because there's so few variables that we included in this block. Okay, now let's go to the actual interpretation of these coefficients. Okay, remember that we want to go straight to this EXPB, which is the calculated odds ratio of this log odds value. This here is that coefficient that is very difficult to make sense of. So we want to use the odds ratio here. Okay. Again, remember that an odds ratio that is greater than 1 means that there is an increase in the odds of the affirmative response. If it's less than 1, that means there's a decrease in the odds. Okay, so in this case, we can see both religious nuns and religious others both have a super great increase in the odds of saying, yes, women should have the liberty and freedom to abort for any reason. And this is compared to Protestants. So when compared to Protestants, religious nuns and religious others have an increase in their odds of saying women should have the freedom to have an abortion for whatever reason. If we look at Catholics, we see an odds ratio of 1. So this means that they don't really differentiate in their responses from Protestants, which are the reference group. Okay. Again, when you're looking at this value here, you want to see if it's statistically significant. In the case of religious nun and religious other, these odds ratios are statistically significant, meaning that this relationship that we are seeing is not occurring by chance. Okay. All right. The next part is block 2. This is where we add the remaining variables, the control variables. Okay. If we go down to the the model summary, we can see that the R-squared has increased to 0.10, which is good. That means that by adding the remaining variables, the model is doing a better job at assessing the outcome variable. Okay. All right. Let's go down to the variables in the equation. Okay, we can see here denomination, very similar results. Nothing has changed even when we account for control variables. Now let's go ahead and just look at control variables that are statistically significant. First, age is significant. If we look at the odds ratio, it's less than 1. So that means that as age increases, the odds of saying yes to abortion decreases. Okay, so as you get older, you are less likely to say abortion should be something women should get under any circumstances. Okay, that is statistically significant. If we look at education, the odds ratio is greater than 1. So that means that as education increases, the odds of saying yes, women should have the freedom to abort increases substantially, and that is statistically significant. And that makes sense. Typically, more educated folks tend to be more liberal in their perceptions of things like abortion. Okay. Let's look at income. Actually, income is not significant, so we don't have to worry about that. Number of children. As the number of children increases, the odds of saying yes, women should have the freedom to abort, decrease. Now that's interesting. And that might make sense too, because people who have children already might be more inclined to believe that, you know, all life is life. Life is life, and, you know, you shouldn't abort a child. But that's because, you know, they have children of their own, and that might influence their perceptions on abortion. Okay, that is statistically significant. If we look at race, other race is significant. Again, remember, this is a dummy variable, so we're comparing it to the omitted category, which are whites. So when compared to whites, people of other race have a decreased odds in saying yes, women should have the freedom to abort. Statistically significant at the 0.10 level. This makes sense. People of other races, like people from Latin America, from other countries, tend to be a little more conservative in these types of social values. Okay. Marital status is not significant. Okay. That pretty much, you know, sums up binary logistic regression. Make sure you have a pretty good understanding of how this works and why we use it. If you have any questions or concerns, you guys just hit me up. You know how to contact me. All right, guys, best of luck, and I'll talk to you soon. Bye-bye.